Hello, hello! Welcome to the stream. David Snowpeck here from Snowpeck Games. How is everybody doing? What are you guys working on this week? How are your projects going? Let me know in the comments. That will get you a cool little character on the overlay as well. I always love looking at those. Give me a moment to fidget with the overlay here. There's one more button I gotta hit. What is it? Oh my god, I created this overlay. How hard can this be? It's one of these buttons. There we go. Okay, let me move it over to the right screen, make it into an actual overlay. By the way, this overlay is a Godot game that we built on stream some months ago. And I just gotta hit, I think, one more thing, and then it should be running. All right, let me know if the overlay is working. I hope that it is. Ricardo says that he got some PRs merged. Awesome. I remember we were looking at one of your PRs last week, but I already forgot what it was. I'm sorry, but I already forgot what it is. Please let me know what your PRs were that you got merged. I am very curious. For me, I'm feeling good today. You know, I'm super tired. I didn't get nearly enough sleep last night, which I guess I say like pretty much every week, but I'm feeling good because this intro video to my tutorial series on implementing rollback netcode in Godot has been just like driving me crazy. I've been having the hardest time getting it done. I've been working on it for like 3 weeks. I wrote it and recorded it and had it all ready to like publish on Monday, I think. But then like Sunday night, I'm looking at it. I'm like, no, this is terrible. I got to start over. So I started over and like rewrote it and recorded it again and wasn't really happy with that either. And then finally last night, this is why I was staying up way too late. I think I finally got it. I think the series is finally going to start. The intro video isn't even, no one cares about the intro video. I mean, not really. People care about the second video where we start like building things. But anyway, I'm happy that it's done. So I'm feeling good, a little bit tired, but otherwise doing all right. So, yeah, last stream we were working on WebXR stuff, and it was a good stream. We set out to solve a problem. We solved it. I made a PR for the work that we did. I'm going to try and find it. I probably won't. Searching for PRs on stream. Not a great move. But anyway, I finished up the work that we had done on stream, made a PR, and it got merged already. I guess you can take my word for it. You don't need to know. You don't need the proof, do you? Am I trustworthy enough? Oh, Ricardo's talking about his PRs. 3 different ones, fixing some animation import, option button, and mesh library. It was the animation thing I think we looked at last stream that we were talking about. Yeah, fixing touch events. Using smartphone AR with WebXR merged, yay! So I'm happy about that. AR is still not terribly great. The support for AR and WebXR and Godot is still not terribly good, but it's getting a little bit better, and I am happy. So this week, what I want to do on stream is take a look at some stuff with SG Physics 2D. So over the last 2 weeks, maybe even 3 weeks, a whole bunch of people have started using SG Physics 2D, which is my deterministic 2D physics engine for Godot, and sending bug reports and MRs, which is awesome, but I've been doing a pretty crappy job of keeping up. I think the first bug report was from Adrian, the buddy Adrian on Discord, who has helped me out with playtesting 2 times. So I feel like I owe Adrian to help him fix his bug, but his is one of the ones I just haven't managed to get around to. So we're going to look at that on stream. Actually, let me show it to you. He sent a really awesome reproduction project, and that is just to say that a solid minimal reproduction project is awesome. As an open source developer, getting that from someone reporting a bug is just perfect. There's usually, when someone reports a bug, like just an inordinate amount of time spent on recreating that bug. Hi, BimDav, how's it going? I am going to be looking at your MRs and merging some of them, I think, on stream. Sorry for not getting to that yesterday. Just too many things going on, but we're going to do it. We're going to do it right now, or maybe not right now, in a little bit, a little later on the stream. So let's jump over to this reproduction project that Adrian sent me. Adrian actually discovered a bunch of holes, a bunch of missing pieces in SG Physics 2D that we're going to need to implement at some point. His game is a 2D side-scrolling game with like gravity and stuff. And because the game that I was building, SG Physics 2D for Retro Tank Party, is a top-down game, I kind of left out a bunch of things that are really nice to have in 2D side-scrolling games with gravity. But he had a whole bunch of workarounds. Like I think I have his project somewhere. But he put like some extra ray casts and like an extra collision shape on the bottom to kind of like check, am I standing on the ground, and all these different things that the physics engine should give you, but at the moment SG Physics 2D does not. We can fix that though. Maybe we'll even fix it on stream. It depends on how quickly we get through everything and how much we're able to tackle. So Adrian sent this minimum reproduction project, and you can actually see the sprite is kind of like sliding down the slope, which I don't think is supposed to happen. But that's not the bug. The bug is we move to the right and it moves the appropriate speed. We move to the left and it moves super slow. But not always. Like it'll move quickly sometimes at first and then get stuck. And I want to try and figure that out for Adrian. I have a suspicion, and it would be awesome if this is the case, that one of the MRs that BimDav made might help this. We will see. His change was specifically addressing where you have like two collision shapes that are right next to each other, and then you accidentally end up hitting like the edge, the corner of one of them, rather than just sort of moving over to the same face on the second shape. And his fix involves like rotating the collision normal a little bit, or not the normal, rotating the, when we're doing move and slide, we slide the motion vector along the normal of the shape that you've collided with. And he has it, I think, sliding it a little further up. We will take a look at that in a little bit. It would be super cool if it also fixed Adrian's bug. What did BimDav just say? I need capsules in my game, so I'm doing capsules. Sweet! You should be streaming too. We should be dual streaming this. Awesome. Yeah, capsules should be really easy. Basically, you get all of the... oh my god, it's been so long since I've been in this code. I'm like forgetting the terminology. What do they call it in SAT? Let's go look at some of our shapes here. SG Shapes 2D. Is this what I want to be looking at? No. These are the shape resources? No. Okay, let's look at the code. Anyway, it's essentially you get all of the axes. You get all of the axes for the rectangle that's sort of contained in the capsule, and then you get the individual axes for each of the circles on the end, and then you just test those 6 axes against whatever the axes are of the other shape, and you're done. And we should have all of the infrastructure to do that already in the physics engine. Someone else was asking for that. Maybe it was Valozard. It's on the list. There's an issue for it already. You can make your MR reference the issue number once you're ready to submit that. I looked at the code from Godot, and it is, for once, rather simple to understand for SAT. Yeah, the way that Godot wrote its collision code, I mean, it's fine. It's fine. It's a very C++-y way of doing things, but there's like templates all over the place. There's like intermediate classes that only kind of make sense. Like they don't make real-world sense. They only make sense in sort of like a C++ object-oriented programming way. So it's pretty confusing to read, but I don't know. Get used to it, I guess. I hope. All right, so what were we doing? What was I doing before I went off on this tangent? We were going to look at Adrian's bug today. We're going to look at BimDav's 2 MRs. Depending on how much stuff we get done, we may look at adding is on floor, is on wall, is on ceiling to SG kinematic body 2D, which, like I mentioned, is something that would be very helpful for side-scrolling games with gravity. And I have this idea. This is probably the most involved thing that we could work on, and so we won't work on it unless like we finish everything else. But I have this idea about changing the way that the collisions work. Let me draw a little picture. So currently, trying to do the thing that gets this unweird. All right, is it unweird? So currently, if you have two shapes, let's take two rectangles, and one of their edges exactly overlaps the edge of the other shape, this will count as a collision. And this creates some problems in that the distance between them is 0. Now, the way that we're calculating the normal vectors involves taking the separation vector. So let's say you have two shapes overlapping normally, and we get the separation vector, which is the minimum distance and direction you would need to move the shapes to make them no longer overlapping. So this would be, I think, the separation vector for this collision. And we're using that to come up with the collision normal, which in this case, I think would be a unit vector coming from this face. But if there's 0 separation, how the heck do you make a normal vector out of that? Because you have a vector with 0 length, which is like totally meaningless. The other problem is with this separation, there's a number of cases where we're using the separation to unstuck objects, to unstuck collision objects. And if we calculate the separation and move the object by the separation, it doesn't move them to a position where they're not separated anymore. It actually moves them to a position where they are exactly overlapping. So it would move it over to here, which would still count as a collision, which is problematic. So what we're doing throughout the code is we are adding 0.5 every time we are making a separation vector, we're adding 0.5 to it to account for the fact that we can't have them be exactly overlapping. I mean, I guess we could add our epsilon value, which is basically just 1, because we're using fixed point numbers. So like 1 is the smallest possible number we're able to represent. I hope that makes sense. But I like tried that, and it was also problematic because like we'd end up with I don't know. I forget exactly what it was, but it was weird. And maybe, you know, implementing this thing that I want to implement will turn out to be equally weird. But the thing that I would like to try, it might not work, but I would like to try changing our collisions such that overlapping exactly is not a collision. That you actually have to be at least, you know, 1, our epsilon value overlapping the other shape to be counted as a collision. So then we will always get sane separation vectors, which will help our normal vector calculation. I can kill this adding 0.5 thing, which just bothers me. It's arbitrary. 0.5 in a pixel game, like a pixel art game where you're at, you know, just 1-to-1 zoom, is a lot. Like that is a pretty big distance. And if you're moving, I don't know, not that many pixels per tick, and this is setting you back half a pixel, like that could have a noticeable effect on your movement. So I don't know. I just don't like it. I want to get rid of that. Anyway, that's what I want to work on. Anything going on in chat? Nope. Okay. Let's get started. I think the easiest thing to start with is just merging some of BIMDAV's stuff, because BIMDAV does awesome work, and I think we won't have that much to do. Let's take a look at the merge requests. The easiest one, BIMDAV is adding a SG YSort node, so basically exactly YSort, but it inherits from SG fixed node 2D. If we look at the code, it's, I think, probably doing exactly the same things as the normal Godot YSort, which is really just interacting with the visual server. which might make you wonder why we even need this if the code is identical. Well, in sgfix2d, we have this thing where you know how like a node will inherit the position and rotation of its parent, like its position is relative to its parent's position. In sgphysics2d, that only happens when its parent is also in sgfixnode2d, because we're changing all of the position and rotation and scale to use fixed point numbers instead of floating point numbers. That's kind of the whole point of sgphysics2d. And so we need to have it be fixed point numbers all the way down, so you can only inherit position from another sgfixnode2d. And if you want to use a ysort node, you need to also have it inherit from sgfixnode2d. So I think I'm just going to verify that. I'm going to take a look at the code for the built-in Godot one, which I hadn't had a chance to do yet, which I think is y_sort, y_normal sort. Why am I not finding it? Just sort. Am I like, do I have something messed up in VS Code that it's not like searching into the build directory? I just created this new workspace in VS Code because I've been basically using the same retro tank party workspace to do like everything. And now that I'm not actually working on retro tank party, I'm working on the sgphysics2d directly. I figured it was time, but it does look like it's doing some kind of thing where it's like, I don't know, why is everything grayed out in here? That's just like random. Oh no. Are we gonna have to start by debugging a problem in, yeah, everything. Everything's just being grayed out. I wonder if it's because there are some VS Code files stuck in my Godot 3 directory. I just copy and pasted it from my old Godot 3 directory, so that's certainly possible. Let's try that first. By the way, my plan is to have sgphysics2d working for both Godot 3 and Godot 4. And my idea for how to do that is to take all of the classes in sgphysics2d that are the internal classes, decouple them entirely from Godot. They are currently coupled with Godot. We're using like Godot containers, where we don't really need to. We could use like containers from STL from the standard template library, or we could make our own containers or grab some other third-party thing depending on if we feel like we need special containers with special properties. I don't think we do. We could probably just use the STL ones. But anyway, decouple all of our internal classes, which those are like this internal directory, which is like the real physics engine. And then all the other stuff, these are interfaces to Godot. And they're currently Godot 3 interfaces, where we are doing, you know, GD class and all this stuff and bind methods. But my idea is we'll take this internal directory, completely decouple it from Godot, move it to some common directory, and then we'll have the Godot 3 module use that code, and then we will make a separate GD native, or not GD native, GD extension, because this is Godot 4, which creates similar bindings, and also uses that same code from the common directory. And my plan is to start messing around with that once Godot 4 Alpha 1 comes out, and it almost came out yesterday. Remy was talking about on the maintainers channel on Rocket Chat, like, should we just release Godot 4 Alpha 1? And it ended up not happening, and I don't know the details behind that, but guys, it's like really close. Like any week now, Godot 4 Alpha 1 is going to come out, and then I want to start poking around with that, because I would love to have both Godot 3 and Godot 4 support. Anyway, what was I even doing? I was attempting to figure out why VS Code is ignoring this. Let's just delete that, see what happens. Okay, let's go back to our build Godot 3 directory. Why are you ignoring this directory? Anyone know VS Code well to know what I might look at to see why the heck it's like not including this directory in the workspace? It builds it fine. It builds Godot fine. Like this is running from VS Code, but it just like isn't including this code as part of the project. Maybe I need to look at like the workspace settings, folders. Refresh, maybe refresh after I deleted that VS Code directory. Maybe do what you always do in technology, turn it off and turn it on again. Let's kill all this stuff. SGPhysics2D, close you, restart VS Code. We have turned it off and turned it back on again. Let's see what happens. Go 3's not grayed out yet. All right, let me try searching for something in it. Y sort. What is happening? Is there like a button I can hit to reindex the project? Preferences. Settings. Oh, BIMDev says he forgot to modify config pi for YSort. Okay. Well, I guess we won't merge it. We can at least review it though and see if everything else is ready. Or if you like really want to fix it right now. We'll really work in real time here. Oh, this is so annoying. Okay, Google. Google will be our savior. VS Code ignoring folder in search. Oops. Folder? Short answer is to comma separate the folders you want to ignore. But I don't want to ignore. I want to include. I want to include. Start work. Search expense. Search terms. Find in folder not working if the folder is excluded in settings. How do you hide or exclude? I want to unignore. I want to do the opposite of ignore. Files, preference settings, user workspace settings, filter for search. Let's see if it's ignored in here for some reason. I mean, folders, should we like explicitly add the folder? What's your little I here telling me? Or exclamation point, not an I. Do I have to hover? Unable to resolve workspace folder. Interesting. Did I leave like a workspace file in here? Oh, this is such a dumb thing to be stuck on stream. Why is my text editor not working? Unable to resolve workspace folder. I mean, that's what it was, right? It was build. Oh no, okay, no, it's dot dot. I gotta put dot dot build Godot 3. Okay. You gonna index it? You gonna index this for me? YSort? YSort, it's there! Oh my god! Okay, let's take a look at this. So this does look identical to the code that BIMDev has here. We have sort enable, sort disable. It just messes with the canvas item in the visual server. We're binding these two things. Constructor, all good. Cool. So I think that's fine. Whenever... Oh, let's build it. Let's build it. Let's actually grab the code. We'll build it. We'll test it. We'll make sure it does what it says it does, or at least the node appears, right? Which might relate to the missing config.py. Let's go to... Oop, I will clear so you guys can actually see what I'm doing. We need to grab this mr, so git mr origin, and what is this? mr2 origin 2. All right, so we should have the code. Just check the diff really quick to make sure it's good. Oh, there's some Windows line endings in there. Hopefully Git will remove those. And let's get VS Code to build our thing. Build it! Oh, and another C++ stream with all of the waiting that implies. Is anyone playing anything cool this week? I actually have not played much this week. I started playing Fallout New Vegas, which I'd never played before. I love Fallout 3, which I know is the one that everyone hates. But I liked Fallout 3, and everyone always says New Vegas is so much better than Fallout 3, but I'd never played it, and it came to Game Pass relatively recently, probably back when Microsoft bought Bethesda, and so I was playing it on my Xbox Series S, and that's been pretty fun. I've only put a couple hours into it, though. I haven't really gotten down to the meat of it. So far, it just kind of feels like Fallout 3, but less dense. Fallout 3 was super dense. Like, you would trip over another, like, landmark just walking, I don't know, anywhere. Whereas, like, I've been in this little town for a while, and it was actually kind of hard getting across this little town. And I just moved to the next town in the story, and even that one, like, I don't know, it's supposed to be occupied by this force of bandits or whatever, and there are like 3 dudes there. I killed the 3 dudes, and now everything's fine. Maybe they're in a building, and I haven't found them yet or whatever, but... Uh-oh. Oh, no. Stop. Halt. Halt. Crap. So this came up earlier when I set up my new workspace, and I added a new commit to the project. I'm keeping the Godot source code within my same directory as sgphysics2d, just because that's easier for me to manage. But that means that the Godot editor will try to import everything that it finds there, all of the assets. And I added the stuff to make it ignore them, but it is in the main branch, which is not in BIMDAV's branch. But this is fine. I'll delete the things. I just did it. I remember how to do it. Let's just search for ysort. We have our sgy sort, which appears to have the docs. I actually didn't look at the docs. I had asked BIMDAV to add them, but I hadn't checked them out in here to even verify if they were there. They are. That looks cool. I wonder what the implications are of leaving the file out of the config.py. Let me just take a look at the config.py and see what's in there. I don't remember needing to do anything with the config.py before, honestly. Like, I think I just used the boilerplate one, and it's always just worked. That, I guess, would be in Godot, modules, sgphysics2d, and the config.py. Oh, the doc classes. That's what it's missing from. It seems to find the docs just fine. I don't know why it needs it, but yeah, I guess we'll need to get that in there. Oh, okay. Well, yeah, we should still get it in there. I use DocTool. I don't know if you used DocTool to create this XML file originally, but it's pretty nice. If you add a property and the docs already exist, it will just insert the new XML for the new property without messing up any of the other stuff you already have in there. So we need to get in. I mean, I guess I could just add it. I could just add it on stream unless you did it. Oh! BIMDAV says, Windjammers 2 was released yesterday. It's a 2-player game with rollback netcode. Cool. I actually have not heard of that. Windjammers. Windjammers 2 official website. Show me something good. Come on. Come on. I don't even know what kind of game this is yet. Give me something. Ooh, that's loud. Okay, so it's like a fighting game air hockey kind of thing. That's cool. That's a really creative concept. Yeah, let me just I'll just add it. We'll unless BIMDAV did it in the meantime, let me just refresh this to check. I don't want to invalidate his work. Oh, cool. So he added it. Awesome. The change is in there. So I now see it here. Okay, cool. I think this is fine. This is good. I didn't test the functionality, but I think it's going to be okay. I assume that BIMDAV did, because BIMDAV has been doing such great work on this. Pipeline status, is it actually running it in the pipeline? I hadn't been paying attention to that. No, I think I have pipelines for merge requests turned off. So I don't know why it's just going on here. All right, so I also changed some settings on the GitLab project to try some new stuff that I haven't used before. I'm going to try to use GitLab's squash and fast forward feature, which is why it has this rebase thing here. Merge blocked. The source branch must be rebased onto the target branch. I don't know if this is going to work. Let's find out. I'm going to click the rebase button. Rebase in progress. Check if merge request can be merged. Sweet! Fast forward merge without a merge commit. Squash and fast forward. We can modify the commit message. This seems mostly fine. I'm just going to add fixes number, what is this, number 2 to the front of it. And let's merge it. Let's see what this does. Previously, GitLab had this really annoying, and it's going to run the pipeline now. It had this really annoying habit of always creating a merge commit. And I know they've been working on this because I was on the issue where they were working on it, and it appeared on Drupal's GitLab instance before it was on GitLab.com, so I was able to use it there. But this is my first time using it for real here. And if you look back in the history, I merged something else from BIMDAV, and it generated this just useless merge commit. Merge branch main into main. Yay. We don't need that commit. That commit is lame. We have the commit with the actual functional changes from BIMDAV here, and it looks like this worked. It put in just one commit. That's awesome. I like this setting. I'm going to put this setting on all of my projects. All right, let's move on to the next merge request. This is the more interesting one. And I did not check if BIMDAV had updated it per my comments, so we might not actually be able to merge it. I'd put the one comment that I thought this code should go someplace else. And I think it has not changed. Okay, well, we can still test it. We can still make sure the functionality is good. If I'm feeling ambitious, I can move it. Or if BIMDAV wants to, although I know he's busy working on something else. I don't want to totally derail you, man. But let's check it out. Let's check it out. I'm also very curious to see what effect it has on Adrian's test case. So let us switch back to the main branch. We're going to pull it. Then we are going to get the other MR. So get MR origin. I believe it is number 3. No, we can get rid of this. Where's the folder? Come on. I only have so many frames. Okay, it is number 3. Merge request number 3. All right, I'm just going to make sure the changes are there. Oh, and this one has a test case, which is awesome. Let's try the test case before we compile it, so we can just see when it's not working. So this would be it's a gut thing. So let's launch gut. That didn't do what I thought it was going to do. Oh, it's because it's using a method that doesn't exist. Can we at least watch it? Does gut have an option for that for us? Jeez. Okay, let's just get rid of all the asserts. Just want to see it. Just want to see it. Okay, can we pick a particular test? I'm going to test, I think it's SG kinematic body to D. And I want to run the selected test. Is there an option to show me the scene as it runs? No, there isn't. That would have been cool to actually visually see it. Maybe what we can do, at least to make sure that the tests fail before the change, is just compile it with the API change, but comment out the functional change that's meant to fix the problem. So let me just quick git checkout -- to remove my local changes. And then let's close the editor. And go find the code in question. I think we want to look in SG fixed vector to internal. And it was a change to the slide method. And to do this, we're going to just add return original slide like that. And this rest of the code here will just not run. The compiler might yell at me about that, so I'm just going to comment it out really quickly. All right, let's build this. Oh, moving collide 3 TSCN. Okay, yeah, we could probably open the scene directly because I saw that you had put the movement in in just underscore process, which should run even without the test. That's an awesome way to do that. So we'll take a look at that too once we're done compiling. I don't want to confuse my computer too much by launching the old binary. Weird things happen. How many eyeballs do we have going? I'm always curious about which topics perform better or worse, like what things people are more interested in. Restream's telling me 0 eyeballs. I know more than 0 people are watching. Here, let me do this on my main computer. The overlay will stop for a second. Ah! And it started to open up on my other monitor. Let's move this terminal over here. Okay. Let me go see. Oh no! Unless Restream is lying to me, it's telling me 2 people are watching, which I guess is BimDav and Ricardo. Although, you know, it does sometimes lie. It doesn't always get it right. Frequently, it'll tell me weird things that aren't true. But I guess it might mean that physics is unpopular. I don't know. Okay, so first things first, I want to just run the test and see that the test fails. There we go. We're getting lots of zeros. This should be with the normal code without me commenting out that stuff. I can just verify that really quick. I always have this paranoia when I test something that I'm not actually testing what I think I'm testing. Like I'm testing a cached thing or an old build. And because that stuff just like, it adds like hours to working on something where you're like, oh, that didn't work. So then you know, move to something else, but really it did work because you were testing the wrong thing. Okay, so it looks like this is uncommented. So we appear to have tested the right thing. We'll go to the scene and we'll run the scene. Do we need to enable visible collision shapes? Okay, I guess we do have that already. What? Non-existent function has node on nil. Maybe we can't just run the scene. Or did I run the wrong thing? We're on the scene. Run this. How are we even getting to this? So move and collide. Oh, it's because the scene itself is a test. It's a gut test, so we can't run it. It's gonna try and do all of its like magic where it's overriding some stuff. Although no, this is weird. Why wouldn't this work? Load this, get instance. Why would that be nil? That shouldn't be nil. Da, 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 da. That's just weird. Let's what is BIMDev saying? Ah, the extends is in error. Sorry, I don't know why I added that. Yeah, I don't think this makes sense because the top level node here is a node 2D, so this should be extends node 2D. I'm just gonna change that. I'm surprised that didn't error out when we were running the test itself, because that's just, I mean, it's just wrong always. It might have just worked on accident. Okay, here we go. Oh, that one got stuck. Those two worked fine. Does it always go like that? Does it always have the bottom one get stuck and the top two work fine? Okay. It's heartening that it fails exactly the same way every time. That's really nice to see it visually too. That also means I misunderstood the problem a little bit. Because I had thought the problem was with shape edges, and this appears to be a single shape, right? Why am I not actually seeing the shapes in the editor? Like, I feel like I should be seeing them. Is there something like hiding the shapes? When you run this in the editor, BIMDev, do you see the shapes? Because like they should be there. If I open up some of the other tests where I know that the shapes are there, like the demos, the move and collide demo, for example. Yeah, okay, I'm seeing the shapes here. I'm seeing even the polygon. But why do I not see them here? Are they created dynamically? This, I'm not crazy about this, multiplying a floating point number and converting it. Dealing with a small number like 30 with no fractional component is probably fine. But I would prefer to keep floating point math out of these tests just in case. So like doing this instead as, let's say, SG fixed vector 2, and a right we do SG fixed 1 times 30, which will do just integer math and a y of 0. I'd rather have that than the floating point conversion. I just don't see. Did you tell me in chat? This case, wait, no. Okay, he's just talking about the actual problem. Okay, I will read that in a moment. I just want to see where the heck these collision shapes are. Like, why do I not see them visually? So static body is at this position. I don't know what that position is. Okay, that's a really big position. Maybe they're like way over somewhere. Here we go. Okay, the screen is this big. And they're over here. Okay, cool. And is this scaled? Is that why it fits on the screen the way it does? Let me look at the test. Sorry, I'm like down in the weeds about a detail that probably doesn't matter, but I just want to understand what's going on. It doesn't look like it's scaled. That's just weird. That's just weird. Okay. So, let me look at what BIMDev wrote here. My fix helps with the edges case, but does not completely fix it. This case is weirder. Only one slope, but the kinematic stops. I have to have big collision shapes, as I use in my game, to have the problem. Maybe because of the fixed half that we add. Maybe adding the half a pixel works fine for small shapes, but causes a problem with big shapes because it's not as big of a movement. Let me take a look at the math that's added here. So we do a normal slide. Then we get the length of that slide. If the original slide length equals 0, should that be able to happen? Should we be able to have a slide of 0, a length of 0? So the normal vector is supposed to be a unit vector, right? And then we take the current vector, which can be any length, subtract the normal vector, or subtract the normal vector times the dot product of the normal, which means, okay, this is why I'm not a math expert here. I have to like try and think geometrically what the dot product means every single time. So we have our vector, our motion vector, and we are colliding with a shape. Let's say its normal vector is pointing this way. The dot product of the current vector on the normal vector is projecting it onto it. Or is it the other way around? Are we projecting the normal vector? No, we're projecting the motion vector onto the normal vector. Maybe. And then subtracting that from our motion. So I mean, yeah, it could become 0. It could become 0 if it exactly cancels out the motion. So if the slide length is 0, we return the original slide. Then we normalize the original slide. We get the dot product of the normalized slide vector against the normal. What is that doing? So we've already come up with our slide vector. Oh, and we're trying to, so it looks like he's just using it to determine the direction that the slide vector is pointing. So if it's pointing away, then we return the original slide. But then the next case would be if it's pointing towards the normal vector, then the objective is taking the min outward dot and subtracting the outward dot. So this, I guess, is the difference between the vector pointing us in and, not. So we're calculating a correction by multiplying the normal times the objective. And then we are adding the correction to the normalized slide vector times the original length. Okay, so we're unnormalizing it. Interesting. Okay, so it seems like we're just tilting the slide vector a little bit away from the shape so that we don't get stuck. The thing that I don't understand is why so much of our motion is getting eaten up here. Like we collide with one shape, and we take our remaining motion and slide it. Shouldn't that continue to retain the same amount of motion? It's just redirected in a different direction. Or maybe it's that it is retained, but our slide isn't severe enough. So I guess that's maybe what this is. It's making the sliding point a little bit further away, and then that just reduces the number of times we collide, because we do have a limit. We have a limit of 6, I think. I think that must be what's going on here. Hey, The Clean! How's it going? Thanks for coming to the stream! Oh, interesting, because big collision shapes implies greater speeds, so the fixed half is small compared to the speed of the movement. Okay. In theory, we should have original slide dot normal equals 0, but we do not, probably because, you know, a lack of precision. We redirect the motion, but we bump again, and we get the number of slides greater than 4. Okay, we're only doing 4 slides? I thought we were doing 6, but okay. It's probably just lack of precision from fixed point numbers. So if we were to draw this, let me start a new canvas here. We have the, I guess it was a circle moving this way. The slide is supposed to redirect our motion to be perpendicular to this face, but it's not perpendicular. It's slightly pointing inward, and that is causing us to keep colliding with this side until we hit our max number of slides. And it looks like BIMDAV's change is just trying to angle this vector more out. I wonder if there's a way to like really precisely figure out like what vector we need to slide to so that it is not 0, but as close to 0 as possible. Because it looks like you're adding a fixed amount. But can we like figure out what the math is backwards so that we can say we want to ensure that we have a dot product that is positive? Right? Because that's how dot product works. Man, okay. This is math that I learned like when I was in high school, and every time I have to do it, I have completely forgotten it, and I have to relearn it every time. So when the dot product is positive, does that mean that the vector we are getting the dot product with, we're pointing away from, right? See, this Wikipedia page is purple because I probably come here a lot. Okay, so oh my god, this is the worst description ever. Anyway, I'm just going to assume that that's right until someone corrects me in the chat. That if it's positive, it means the vector is pointing away from the other vector. 0 is perpendicular, and negative is towards. I'm just going to assume that. If I have that backwards, please let me know. So, could we do it backwards? Well, let's just compile this, see how it performs. I would be curious to see how it affects the other tests. This might be something that I might need to spend some more time thinking through to see if there is a way that we can ensure that it's always going to lead to a vector that points in a good direction. Yeah, so BIMDev is using the smallest possible correction, but what if the smallest possible correction sometimes isn't enough? What if that still has us slightly angled into the shape? And that's what I'm kind of worried about. If there's a way to... And maybe your math already accounts for that. I'm not sure. Math. I might need to run through like a couple of these on paper or something to oh yeah, let me kill this. Where is it? It's here. So let's go to that test. We're just going to run the scene, move and collide 3. Just check it visually first. And it doesn't get stuck, so there is that. Let's run the test really quick. I'm going to assume those are going to pass. Yep. And let's try Adrian's example. I'm curious to see if this helps with that, which is not like a big, not dealing with big shapes like BIMDev is, but I would be curious to see if that has a positive effect here. All right, so moving down, we're going this speed. Moving up, we're going this speed. It's moving the same speed in both directions, at least visually. I mean, it could be a little bit different down, you know, at the exact numbers. But this fixes this problem too. Okay. Okay, I think this is a fundamental problem we do need to account for. Like I said in my review the other day, I do think that this shouldn't be in the SG fixed vector 2 internal class. I'd like to think of, or maybe it should, now that we've talked about this so much. If we can know for a fact, if we can know mathematically for a fact that the resulting slide vector doesn't point towards the normal that we're trying to slide away from, or that we're trying to slide along, then I think this is okay in SG fixed vector 2, so long as it's reasonably fast. Because you would never want to use, you would never want to slide a vector for any reason where it could turn out to still kind of point at the normal. I don't think. I can't think of one. My original thinking was that this method should be like purely just the math, just this, and that the rest of this stuff is specific to our move and slide. And maybe I'll come back around to that thinking later as I think about this more. But right now I'm starting to think like we just don't ever want a vector to slide along a normal and still point at the normal. Not if we can help it. Yeah, because even if you were not using that for like motion specifically, if you were trying to like draw paths or something, or do AI, or I don't know, like you would never want it to still point at the normal. I'm assuming the cool is in that it fixes Adrian's problem too. Yeah, that is super cool. Okay. Should I try to understand this better right now? That is the question. Okay, so if the length is 0, we simply return it because a nothing vector doesn't need to be, we don't have to worry about that colliding. That's cool. The original slide vector normalized. I assume we're normalizing it because we're doing a dot product with the other normalized vector to get, yeah, just this sort of directional information. This part is where I get a little bit confused. Compute the smallest correction vector to get the good outward direction. Minimize correction, squared length under constraint of the objective. So we're taking the outward dot product, which is basically just telling us how far we're pointing towards the normal vector. Or no, that's what the outward dot is telling us. The outward dot is telling us how much we are pointing towards the normal vector. We're subtracting that from the min outward dot. What is min outward dot? Min outward dot, okay, 0.004. So this is the very small value. So we want to take this very, very small value, subtract the amount that we are pointing towards the normal, which will be negative. So we are taking the min outward dot and we are subtracting a negative number, which is adding. You know, we're going to make this bigger than 0.004 degrees. The correction is the normal times the objective. So this is a vector pointing away from the shape that we just collided with, and it is a length of this calculation. So then the resulting slide vector is the original slide normalized plus this correction. So we're just taking the vector and we are, yeah, so we're redirecting the head. Is that the head or the tail? I guess the head. We're redirecting the head of the vector by this amount away from the normal and multiplying it by the original length. Okay. I think I'm getting this. The main thing that worries me about this is the very arbitrary value of 5. Do we know for sure that that is always enough? So we're basically starting with this as the base value and then adding to it the dot product of the original slide and the normal. I mean, I guess I'd have to look at examples of vectors to see if they would be enough. The thing that's shows that maybe it is enough is that we're dealing with normalized vectors here. These are all normalized until we do this one here to denormalize it, to multiply it by the length again. And so maybe when we're dealing it with normalized values, this could turn out to always be enough. Don't crit on me now. Don't crit on me now. Welcome to the stream. Not a game dev. What is the object moving towards the plane? Is it because something is pulling it towards it, gravity, or is it moving in that direction on its own, velocity? I don't know exactly what you were looking at the time. I'm sorry, I wasn't watching chat. Possibly you were watching this one? I don't know, because this one seems to be crashed at the moment. So this is a minimal reproduction project that I got from a user. The problem they were originally having, and this is, I'm pressing buttons to move it. was that when you moved down the slope, you moved one speed, and when you moved up the slope, you moved a different, much slower speed. And so we're agonizing over the math to attempt to fix that at the moment. And previous one, I'm not entirely sure. You mean the one before the one I just talked about? The other one we were looking at was we were in this other demo where they were moving on their own. They were just pre-programmed vectors of these shapes colliding, and the problem we were looking at was that it was getting stuck. How do the tests run if you do fixed one instead? That, I mean, okay, I guess that's a good question, Ricardo, because that is a good question. Okay, let me not get too distracted here. I'm going to answer "Don't crit on me now's" question, and then I'm going to think about what Ricardo said, and then I'm going to go back and read BIMDev's message about the math, which I still haven't read. And I keep opening the wrong project. What is wrong with me? It's the 4 hours of sleep or whatever I had last night. I'm sure that's it. Let me get to the tests. Open up the, not demo, the test scene. This is Move and Collide 3. That's Move and Collide 2. Move and Collide 3. So the issue we were having was this one circle was getting stuck halfway moving along. These are just moving at a fixed motion vector always, because it's part of an automated test to just make sure, did the objects keep moving or stop? Hopefully that answers your question. Ricardo's question, Huff Compton. Va? Is that some new speak? I don't know. Welcome to the stream, Huff Compton. Ricardo's question about what if we run the tests where we do fixed one instead, I think is an interesting question, because it might not be enough, right? Fixed one might not be enough to have it not get stuck, and if fixed one is not enough, how do we know that fixed 5 is enough in every situation? So let's try that. Let's try Ricardo's thing. And while I'm waiting for that to compile, I will take a look at what BIMDev wrote. I'll comment this out so I don't forget what was here originally. Fixed 1, we will recompile, and BIMDev wrote, the math is that you try to compute the correction so that original slide normalized plus correction dot product normal equals objective. Okay. You normalize correction length by taking its derivative and setting equal to 0. The arbitrary value is equal to an angle because it is a dot product between normalized vectors. Yeah, so, but how do we know that the 5 is always enough? And the next thing they write down here, due to, I guess, fixed point imprecisions, even after correction, we are not precisely at the objective, about +2, -2 compared to it. That's why I put 5. So we're dealing with normalized vectors, which is like a fixed set. There are only so many normalized vectors in fixed point math. It's actually a relatively small number compared to, you know, the astronomical number of them that we would have with floating point values. But is there a way to know that we can always use 5? So I guess I'm expecting the thing that we're trying for Ricardo to fail, now that BIMDev said the thing about it always being ±2. Let's give it a shot. It didn't get stuck with 1, but that could again just be this case. It could be that this case works with 1, but some other case would not work with 1, which I assume maybe with your game in particular, BIMDev. Did you see cases where 5 worked, but like smaller numbers didn't? I wonder if we could just like write some code that loops over a whole bunch of different vectors and tries to do this and measure that the dot product always comes out 0 or positive. And maybe that's a good unit test. Maybe that's a good unit test of this method. Let's see what the code for that would look like. I'm just going to remove all of this stuff. And I guess that would be over here in Godot. Let me write a new quick unit test over here in SG vector 2. I'm going to do func test vector slide, or just test slide, something like that. Let me go quick see what everyone's saying in chat. I have this tendency to get distracted and miss chat. Don't crit on me now says, yeah, I see how the objects slide across the plane. Once the plane ends, they can continue on their original vector. I'd expect the object to bounce when it first impacts the plane. Don't let me distract you though. Well, so they could bounce if we had coded them to bounce. Right now we're just testing the slide. You missed the part where we showed it not working. When it was not working, the object would slide for a while and then just get stuck. We are specifically working on the math for sliding. Fixed one did not work for some cases. Okay, yeah. Don't create on me now says, to me, the object is sliding across the plane because it has a velocity in a specific direction. The plane is pushing back on the object, causing it to slide across the plane. Well, it's not pushing back. We're doing a very, very simple bit of math for the sliding. The core of it is just this. We're taking the motion vector and subtracting the dot product of the motion vector and the collision normal. The collision normal, I guess you said you're not a game dev, so I should probably explain that. The collision normal is a vector pointing away from the shape that you have collided with, specifically the plane that you've collided with, and we're multiplying that by the normal vector and subtracting it from the motion vector. I may have said that in a loop because it took me so long to say it, but to summarize, the dot product of the motion vector with the normal vector times the normal vector and subtracting that from the motion vector, which is, it's simple math, but we're having a problem with it being not quite precise enough, causing it to sometimes get stuck when it should always slide. Oh, sweet, sweet. Sorry, I didn't mean to talk down on you, man. I just didn't know. I just didn't know that you had a CS in math degree. Okay, so BIMDAV says, I just controlled the kinematic body and slid it along the slope for some time to find the kind of amount that you're working on. Well, let's, like I was saying, let's make a unit test that does a bunch of these. So how are we going to structure this? We need a vector to collide with, the normal vector. We need some normals. Let's just do one, and then I'll figure out how we're going to do a bunch of them. Let's pick a normal, which is a fixed vector pointing to the left. I like things that point to the left because I like for my main thing to be moving to the right. I don't know why that is, maybe because the way we read left to right. So pointing to the left, and we will have the motion vector, which I guess should we call it velocity? No, we're just going to call it motion. We're only simulating a single frame, so we don't need to think of it as a velocity. And we'll have it move exactly. Do we want it to move exactly right? That'll completely stop the motion. That's not helpful, is it? Okay, let's have this vector point maybe down and left at a 45-degree angle. So we'll point down and left. We will normalize it. And then our motion vector is moving straight to the right. And we are going to, I guess we'll say the motion vector equals the motion vector slid across the normal. And then we want to say at the end, is the dot product equal to or greater than 0, right? Do we have to normalize the motion vector to do that? I think we might. Yeah, I'm not sure. We're not going to use it for anything. We just need to check if it's positive or negative. So anyway, we'll do assert equal. if the dot product of the motion vector to the normal, or not assert equal, assert greater than, assert greater than or equal? Do we have a greater than or equal method? Is that a thing? No, we just have greater than. Okay, we'll just do assert. Assert is greater than or equal to 0. I might be messing up this dot product at the end. Let me just run it and see what happens, and then I can go look at what smarter people are writing to me in the chat. It's always good to have people smarter than you in the chat on your stream. It's perfect. You guys are my brain trust. All right, we're going to run this. Nothing failed. I guess I'm curious in the specific values, though. Let's print some stuff out. So we get this new motion vector. I would like to see what that vector is. We got to do something special to print it because I never added a thing to help print those. I should. So we'll say if we add like a toString method, then we can just print these and have them look a little nicer. So this will be our motion x and motion y. I forgot to put those in an array. And I want to see what the dot product is between the motion and normal vector. And where is it in this whole mess? It might not even appear here. Maybe it appears in the editor. Okay. Cool. No, this seems perfect. So it's getting a... Okay, so you couldn't see this because I just typed it all in, but essentially what we have in this example is... Where's my drawing thing? Is we have a face that is like this with a normal like that. We have some shape. We'll say it's a circle that's moving this way, and it's calculating the slide vector exactly perpendicular in this direction, which is giving us a dot product of 0. Huzzah. That one is perfect. Now what I would like to do is loop through like a whole bunch of example motion and normal vectors and try to see if we can find any that will trip it up, that will get us a motion vector that is, or a slide vector that is less than 0. Now let me go see what everyone's writing. We can maybe try all normal angles and all motion angles. Oh, that's what you're doing. Yeah. I mean, all of them might be impractical, but if we try a whole bunch, I mean, we could try them all because it is a fixed set. But that might take a really long time. We don't want our tests, because I want to have these tests run on CI when we make a commit, and I don't want it to take an hour. Right now, the tests aren't running on commit. It's just doing a build, but not actually running the tests. That's something I have on my to-do to add. Okay, so we have to generate a ton of normal vectors and motion vectors that we know will collide, which we can figure out from the dot product, so that's cool. So let's start with how we're going to generate a bunch of normal vectors. We can't do them all. We can move it some sort of fixed amount from 65536 through to negative 65536. How many steps seems like a good idea? Let's see. 65536, how big are the steps if we divide by 128? 512? I also worry that like perfectly round numbers might always yield perfectly round results. And so maybe we don't want to go by a number that is perfectly round in binary. What if we go by 100? So that would mean that we are 24 off on both ends, right? So then if we do 65536, subtract 24, Does that make sense? That doesn't make sense. No, 65536 minus 12? No, what? 65536 minus 12. No, that doesn't make any sense. We want something that's evenly divisible by 100. Okay, so we're going to be 36 off, right? No, because we don't want to get to exactly down to 0 either. Maybe my original thinking was right. So half of 36. 18. Okay, so let's say we start at 65536 minus 18. We go down by 100 until we get to 18, and the same for the negative values. So we need to do a range thing, and I will have to look up the docs for this because I always forget exactly the parameters here. So we are going from something to something at a particular increment. We are going to go from, where's my editor? Oh, I'm looking at the docs in the editor. That's why it's throwing me off. Okay. Where the heck was I? Here. Okay, so we're going from 18 to 65518 in steps of 100. And hopefully those numbers will be weird enough to catch some weird cases because they are not aligned to round binary numbers at all. I'll say, I guess, positive values. And we'll do basically the same thing with negative values, going from negative 65518 to negative 18 in steps of 100. This still... Why are you complaining? Oh, because I didn't rename the variable. This still is potentially going to take a very long time. Let's do a simple version of this first. We'll do one where we use all negative x's, all positive y's, and have just this same motion vector. So we're going to say for, we'll say pos in positive values, for neg in negative values. We'll generate a normal vector, which is sg fixed vector 2, with the positive, negative, and normalized, and we will crash this motion vector into it and get some data out. We'll remove these print statements so we don't print, what would this be, 10,000 things? We're doing 100 by 100, so that's 10,000 iterations. And just see if this works. This, of course, is not comprehensive in any way, but we can keep extending this with more and more values to try for both the normal and motion vector to see what we get. What is the error? Assertion failed. Thank you, but I don't want you to just tell me the assertion failed. Let's go look at the methods from the test framework. Apparently, assert isn't what I want. Assert not equal, assert almost equal, assert greater than, assert less than, assert true. Okay, assert true. That's what we're going to use. The problem was I was using the built-in assert keyword, which does something different than our test framework, which has its own assert methods. So let's try this again. It's running. It's running and running. Okay, maybe 10,000 times was too many. I'll let this run a little bit more while I look at chat. Testing sounds like a good idea. If some fixed small value doesn't always work, then maybe some iterative process is necessary. That would motivate putting that kind of code in move and slide instead of slide. The thing is that move and slide is essentially an iterative process. The problem is we don't want to iterate too many times. That's why there's a limit on the number of times we slide. Maybe the answer here is we just up the number of iterations because the nature of fixed point values means we're just gonna hit it too many times. Okay, this sucks. It definitely failed a couple of times, but I don't know the values. Okay, let's why can't I close this? Okay, I force quit it. We need to use a different assert method so that it will tell us the values that didn't work. There was greater than, less than. Do we have a greater than or equal to method that it will give us? It doesn't look like it. This is ridiculous. Oh wait, not equal deep, equal shallow, pair deep. Just guessing what it could maybe be called. Okay, another possibility is I just put the message on there manually because I think we get an argument for that. So assert true, and we'll just dump the values into the text here. And where am I putting that? So we want to say what the two values are. We're going to say the motion vector dot the normal vector equals and the result. So that is motion x, motion y, normal x, normal y, and then the dot product again, which I guess I have to copy. I guess I'll make a variable for it. So we'll say dot. Just put dot in here. And while this is running, I will take a look at what I've been missing in chat. Okay. I now wonder if the imprecisions are due to the fact that we compute the remainder value at the same time as the sliding direction. Maybe we could compute the perfect sliding direction by a 90-degree rotation of the normal. You just blew my mind with that. Yeah, a 90-degree rotation of the normal. Yeah, why the heck aren't we doing that? Which is super fast, and then multiplying it by the correct amount to get the sliding remainder speed. There's another iterative process in move and collide to get the closest colliding point in motion that will also max out if you increase the number of iterations in move and slide. Well, so that has to max out because it's a binary search and we can't do it forever. But oh, it did? The normal cert gave the values in the debugger. Ah, Ricardo, you always notice this stuff and I always miss it. But no, you blew my mind, BIMDAV, with the 90-degree rotation. Why the heck don't we do that? Why does this slide method even work like this if we can just take a 90-degree rotation of the normal, which again won't necessarily be perfect due to imprecisions. Rotating at 90 degrees could actually rotate at 89.9 degrees or whatever. But that does sound great. Or would it be imprecise like that? Because okay, so we have how are we getting the 90 degrees? Are we just flipping it to the other side of the axis? Does that get us 90 degrees? Or do we actually have to do it by rotating? Okay, you guys get to witness the way that I do geometric math. I'm holding up my hands and pointing at them like, here's the vector, here's the axis. Let me draw this so this is more logical for humans that are not me. So how do we get the 90-degree rotation? We have the axes here, y and x. We have a normalized vector pointing this way, and we get the 90-degree rotation by just swapping some values to flip it around the axis, right? So here we have this negative x value, which if we put on this side as the y value, so we're taking the y value is negative x, and the x value, hang on, am I doing this right even? Brain, think! So the negative x becomes the positive y, and then the y value, I'm sorry, the x value is the just the y? Just the y? Does that rotate the vector 90 degrees? If so, that wouldn't have any imprecision, right? Is that right? Haha, BIMDAV! BIMDAV came to the same conclusion as me, which is awesome. I always like when I actually get it right. I also like when people correct me, though. I shouldn't lie about that. I like when I don't have to think it through. I can just get it wrong, and then you guys tell me the right answer. All right. So this should be the. Hey, Luca Invaldi, welcome to the stream. X value is positive U or positive Y. Yep, Y. The clean. We don't if we have to rotate clockwise or counterclockwise. We don't know if we have to rotate clockwise or counterclockwise. So can we get the direction of the rotation from the dot product, though? Or we... Okay, so this is fast. The actual rotation, but how do we know which direction to rotate? So that warrants another drawing here. So we have the thing that we are colliding with. The normal vector is pointing here. Our motion is coming in this way. We know that we have to rotate to point down there because the dot product between the motion vector and the normal vector is something. What is the something? The something is, so we are pointing almost exactly into it. So if the dot product is 0, no, if the dot product is 0, that means we're parallel. What do we get if we're exactly not parallel, like, or parallel but crashing into each other? Is that still 0? I might have to do that like just in the editor or something to figure it out. But so if the dot product between our motion vector and our normal vector BIMDAV says, well, the perfect computation is the one that is in the original slide, but it's apparently imprecise. Luca Invaldi says negative something in this case. Okay, so if it's negative, then we're rotating to face this way. And in the other case, we'd have the normal this way, our motion this way. So, okay, now it's pointing away from us. Now it's still pointing away from us. Will this give a different dot product, or will this give the same? It would be great if this one was negative and this one was positive. But I just get myself so wrapped up in trying to remember how these different math things happen. Let me just put some vectors into a test case here and see what they do. I'm just going to comment this one out because it takes a million years to run. Oh, and it ran, and we got some numbers here. So this is interesting. These failed cases are failing with a dot product that is just barely negative, 1 and 2. Are there any cases listed that are greater than 2? Or I should say less than -2. Okay, I'm gonna run on two directions here. I'm doing too many things, trying to think through too much stuff at once. Let's bring this back in. I just want to try. Or no, we'll leave it out because I need to compile before I can actually use this. Let's just try changing 5 to 7. Oh my god. We'll try changing 5 to 7. We will recompile, and we'll see if that fixes that really long test. And in the meantime, I'm just gonna write a little test here for me to just write some math. So let's take, let's say normal 1 equals SG fixed vector 2, and this one is pointing at a 45-degree angle down and to the left, which means we have a negative x and a positive y. And our motion vector is always going to be the same one we've been using this whole time. This one. And the other vector is going, ooh, what are you complaining about? Oh, because I'm still doing this. Hang on. I got to finish something here. Trying to rush me, VS Code? I cannot be rushed. An artist cannot be rushed. Okay, so, and then this one, we're going to do the opposite. We're pointing, we want to point, okay. We're pointing down to the left, and we're pointing, I guess, up and to the left. So that's still to the left, and then up. And I just want to know the dot product between the motion vector and the normal in the first case, and the product with the second vector in the other case. I'm going to print something here so I'm able to find this in the logs. I just want to see what this does. Oh, come on. It's not running because we replaced the binary halfway through. Okay, we are going to have to kill this. And we'll start it up again with the new binary. Luca Invaldi, sorry, I only joined the chat now, but I don't know what you're trying to achieve. Maybe I'm wrong, but the velocity vector dot the normal vector of the wall is always negative. Okay, the clean says, yeah, it is. Okay, so my idea that we're going to somehow figure out which direction we need to go, which direction we need to rotate, is just wrong. It's just wrong. Let's go find my printout so I can verify in very concrete terms that I'm wrong. Oh, but it doesn't appear here. It appears in the editor. Okay, yep, it's negative in both cases. You are right. You are right, Luca Invaldi. So what we're trying to accomplish is we have this deterministic physics engine that is made deterministic by using fixed point math. And the problem is the normal calculation for sliding one vector along a normal vector is imprecise due to fixed point math, and sometimes yields a result that we can't use for the purpose of collision detection because it still points ever so slightly towards the normal we're trying to slide it along. And we're trying to come up with some way that we can precisely slide that vector such that it is either exactly parallel or just a tiny bit pointing a little bit further away from the original face that we collided with. And one of the ideas that BIMDAV had was that perhaps we could just rotate the normal vector, which would be just exceedingly fast and probably precise, right? Because we're just swapping components. We're not doing any kind of calculation on them. It should be exactly perpendicular. The problem is we didn't know which way to do the rotation, and I had this theory because I'm bad at math that we could use the dot product to figure it out. But as Luca pointed out, and my test just verified, that won't work. So if anyone has any ideas on that, that would be really cool. Otherwise, we'll probably end up returning to BIMDAB's original math. I'm going to see what you guys are writing in chat. But before that, I want to just really quick try this test again. Now that I've changed 5 to 7 to see if this tiny change in random magic number is going to help us. Where the heck is this? It's in the unit tests, not for transform, for vector. And this I'll get rid of. And I'll bring back this code. It'll take a long time to write because it does 10,000 iterations, or a long time to run. No time to write. I just had to uncomment it. How are we doing on time? Okay, we only have 20 minutes. We didn't get to nearly all the stuff I wanted to get to. I guess the upside is once we solve this, it will solve Adrian's bug too. Okay, let's see what everyone else is writing. BIMDAB, in theory, if you write it, you always have new motion dot normal equals 0, with new motion equals original motion minus normal times original motion dot normal. But that is not the case in practice here. Cross product is the way. I'm not entirely sure what you mean by cross product is the way. Ricardo says, how about testing the idea of increasing the number of iterations in move and slide instead of changing the slide? That is also something we're trying. This did not help at all. We're still getting -1s, -2s. So, okay, Ricardo, we should probably try that. There's still a possibility, though, that we could get locked into a set of vectors that just always evaluate to something that is pointing in a little bit, because these are fixed point numbers. It could just always turn out that way, and it doesn't matter how many times we slide. So it's possible that we do actually need another iterative process. Like, we could just add values to this until we're not -2, -1. I don't know. Luca and Valdi, you could still use the dot product of two normalized vectors to compute the angle between them. I tested it, but that does not work. That's BIMDAV talking about increasing the number of iterations. Probably it doesn't work for the thing I was just talking about. Luca and Valdi, the dot product is cosine alpha times the length of the two vectors. Cross product is the way to have the direction of the rotated normal. Cross product is sine. So cross product is the way to have the direction of the rotated normal. So we get the cross product. Cross product confuses the hell out of me for 2D numbers, by the way, because I don't have a geometrical way to understand it. But how exactly do we use that? So we'll do the cross product, and that number will tell us, I guess, whether the angle is, positive or negative from or greater than 90 degrees or less than 90 degrees from our position. Hit me with some math, BIMDAV. Like, what would this actually look like if we do the cross product, like not math? Hit me with some actual code. So if we do the dot product or the cross product between, and I actually erased a line I didn't mean to erase here, between the motion and the normal vector, what indicates that we need to do clockwise or counterclockwise rotation? because I would love to be able to test if that works. And maybe this is best handled off stream, because now we're basically just writing this code together. But so here we are rotating clockwise. Counterclockwise would be what? That is, I guess, the same x and y here. So we're still swapping x and y, but we want y to go from negative to positive, and or no. No, this is different. This is different somehow. Let me think this through. We want, so the clockwise rotation is this, and so we are turning the y straight into x because it goes from negative to negative. So the y value goes straight into x, and the y value, this value is I guess positive now, and here it was negative x. What? How am I getting the same thing? I mean, it's the same thing as this, but we're flipping something. Okay, hang on. So from this, we are just flipping the x value and the y value, right? We're flipping, the x becomes negative, the y becomes positive. So it's exactly this, but we're doing like that, right? Is that right? You mathy people, you're the ones who need to be doing this stream, not me. Okay, so let's just run through this one more time to see if this is right. So we have some small negative x value, which becomes a small positive y value, good. And we have some sort of biggish negative y value, which becomes a biggish negative x value, but that's not right. Then this symbol isn't right. I don't know. What is everyone saying? The clean. Okay, not sure. Sorry. Cross product is more like matrix math. Luca Invaldi, if the vectors are normalized, you can solve the problem both ways, cross or dot. I think that you can compute the motion equals the sine of the motion cross product with the normal times the normal rotated 90 degrees. That is the direction. And the amplitude is the remainder. Okay, this I can work with. This I can make into some code here. Although the rotating 90 degrees, I've still fully confused myself on how that works. So we're rotating clockwise. Okay, if this is negative y, then what you're describing would totally work, because the sign will give us either a positive or negative, which would flip both of these. But let me just try this one more time. So the x value that we're going to use here, which is this, comes from the negative y value. X value comes from negative y value. So here y is some negative number, but it needs to be a negative number again. I'm very confused at this exact moment. XY, okay, XY becomes YX, or negative Y, negative X, is that right? Should this really be negative Y up here? Did I get that wrong the first time I went through this? So in this case, X is the Y value. Okay, yeah, it is negative. Okay, it is negative. Okay, so I messed up the first one. So XY or YX, cool. Yep, you guys are right. You guys are the smarter ones in this room. And so That's fine. The motion thing is fine. So then the normal rotated 90 degrees, I can just do one of them, and it will, the sign will take care of it. So let's write some code here. Do we need the original one? We don't. We're going to start with figuring out the rotated normal. So SG fixed vector to internal. This will be, I guess, rotated normal will be, as we said, we're going to swap the x and the y. And we want the new, we'll say motion vector, or motion direction, which will be the sign of the motion cross with the normal. Okay. We'll start on that end. So the motion, which is this cross, or we don't need to, okay. This cross the normal vector, the sign times the rotated normal. So this will pick the correct direction. Why are you yelling at me here? Oh, because we have to dereference this. Or no, do we have to dereference it? No, why is it yelling at me? Fixed and const. Oh, because the sign is not a fixed point value? Okay, fixed. And actually, this will be wrong, because it's going to be, oh my god, why does this have to be such a pain? So it's not just the straight fixed point number, it is from int. There we go. And so that gives us the direction, and then we, why are you still yelling at me? No suitable conversion from fixed. What? So it is returning a fixed point value? It is. Then why were you yelling at me before? No operator matches these operands. Operands are fixed const pointer. I don't understand what it's trying to tell me here. Fixed times const fixed normal vector internal. Is it because I have these in the wrong order? Yes. So we defined an operator on the vector class to multiply it by a fixed point number, but we did not define the opposite operator. Okay, so that gives us the motion direction, and then we return the motion direction times the length of the motion vector, which is this length. Let's see what happens. Let's see what happens. How much time do we have? 5 minutes till I gotta go do other things. Things like work. Work, what's that? We gotta recompile this, and I'll see what everyone has been making fun of me for in the chat. Does sign work with vectors? No, we're getting the cross product, which is a single scalar number. Cross product gives a float in 2D. Yeah, you have to normalize somewhere. Oh, right, then it can totally work. Okay. Let's see. Let's see what this does. There's always the possibility that the imprecision of something else is going to still leave us with the same problem. I hope not. I mean, I don't know what that could be, to be honest. We're dealing with perfectly rotated versions of the normal. Perfectly rotated. It's a normal vector, so it's just straight multiplication. We're not going to lose something like in a division. Only if somehow the motion vector calculation part is weird. I don't know. I don't know what could get weird. Oh, should I have normalized this? All right, well, let's see. Whoa, what is all this? Oh, this is because of the stupid things got imported that shouldn't have been imported. We can ignore that, I think, I hope. Well, okay, no, stop, halt. Let's do a simpler test first. Let's just see if this even works, like at all, on the test scene. And if it does... Nope. Okay, so let's try normalizing the vector like was suggested. Let's normalize this. So that would be this normalized. Get the cross product. Okay, so we're dealing with two normalized vectors. Why? What are you yelling at me for? This applies to instead of to a pointer type. Oh, because I need to change this one now to a dot. All right, C++, you are fun. To get the motion direction distinction normalized. Yes, yep. Oh no, you are okay. We are only looking at the sign. So BIMDAV is actually correct and said we didn't need to normalize it, and I did it anyway. Let's see if that makes any kind of difference. He's saying, don't do it. I'm sorry. Well, we'll find out. I mean, it clearly didn't quite work. It clearly didn't quite work. Even though I don't know how that's possible. I guess we'll run the other test. We'll run the other test. We can always switch back to the not normalized. I think we have just enough time to try again, I hope. The length is not right. The length is not right. Am I getting the length of the wrong thing? This is definitely going to go down in my streaming history as one of the weirdest streams that I've done. Like, we've made no progress and have kind of gone, like, we're writing the code together as we're doing it, which is cool, like, but weird. All right, so what am I going to try real quick before I go and make the changes that BIMDAV is vigorously typing, I am sure. I want to just try this functional test and see if it acts any differently with the vectors, with the motion vector normalized. Yep, I hit the wrong button. Run scene. No difference. Okay, so what is the issue then? The length is not right. So motion direction. Motion direction, which is already normalized, times the length. I mean, shouldn't that be okay? I mean, I guess I'm not sure. I get what you mean by the length is not right. Because the main thing we care about here is that the direction is right. Right? I'm just going to recompile this. I'm just going to recompile this, and I'm going to run that super long test that does the 10,000 iterations, and I want to see how different this is. Like, what is the delta on the dot product? Like, how close or far are we from being perfectly parallel. And what if we are perfectly, or not perfectly parallel, perfectly perpendicular? What if we are perfectly perpendicular, but we're still getting stuck for some other reason? I think it's this dot motion vector. Oh, yeah, I think you're right, because we don't want to just take the length directly. We want to project the length onto the motion vector, because we're actually losing some amount of our motion from the collision. Yeah, yeah. I think you're right. But will that matter here, though? Because shouldn't that just mean that we're moving a little bit too far? But we should still not get stuck. If the angles are perfectly perpendicular, or if the vectors are perfectly perpendicular. Let me try just running this test. Yeah, I can just hit play to do that. And while that's happening, I will poke around here. It's actually nice that we're doing a dot product instead of a length, because a length involves a square root. So yeah, this dot motion direction. So yeah, we're projecting the motion vector onto the motion direction. Well, let's see what's happening here. I think this is going to have to be the last thing. What? Okay, so this isn't getting stuck. Cool. But where's the other one? Where is the other one? Did that one pass? Test slide. Test slide passed. Test slide passed. So it isn't a matter of the angle being not perpendicular anymore. It's something else. Are we just too close to the object? And then the imprecision in the shape of the circle is now causing a problem? I mean, I'm gonna recompile if I can do it quickly enough. And then I want to like try and go for a little walk before I have to do a work meeting. I need to move myself a little bit when I'm transitioning from stream mode to work mode. But let's just recompile this. Yesterday I had cases where motion dot normal equals 0, but I was still stuck. I think it needs to go more outwards, but I'm not sure why. Yeah, I think it's some imprecision in the shape. However, I do like this code a lot better than this code. So even if this isn't exactly right, even if this isn't exactly right, I feel like we're on a good track here, or maybe not. I might change my mind about that later. I'm definitely glad that we explored this. Because this math does sometimes yield a vector that does point a little bit into the normal. We were able to verify that through our 10,000 iterations. We were getting a handful, not that many actually, like 2 dozen, 3 dozen iterations where it was pointing slightly towards the normal. And now that we have the ability to come up with something that is exactly perpendicular, we know we're not doing that. The thing is, do we need to expand the angle a little bit? And is there an efficient way for us to do that? Yeah, so we're still getting stuck, even though we have this perfect you know, this brings up another thought to my head, and I'm just gonna talk about this, and I'm getting off the stream. I'm gonna respect your guys' time. I'm gonna respect my time. But in in SG kinematic body 2D, when we do move and collide, we start by getting our body unstuck if it's stuck. Then we go to the kinematic motion over here. What if we need to get ourselves unstuck periodically? Like, rather than just doing kinematic motion, or no, shouldn't we be doing... Okay, hang on. Move and slide has us moving, colliding, and then if there was a collision, we slide our motion vector along the normal, and then we do move and collide again, which should get us unstuck. It should get us unstuck before it moves on to the kinematic motion. Why isn't that working? Why isn't each iteration of move and collide unstucking us? I might need to like walk through this in the debugger later to see exactly what is going on there. But this was a really interesting stream, guys. Thanks for doing this with me. Thanks for writing some code and doing some math, even though I'm terrible at math, together with me. Thank you for your help, because you guys are good at math. And yeah, I've got that video about the intro video to the tutorial series about rollback netcode in Godot coming out probably on Monday. And yeah, I'll see if I can sneak in some time to really hack on this over the weekend or something. Thanks everyone for coming, and I'll talk to you next time. Bye-bye.